Alright, in this presentation we're going to do a clone, yes, another clone of Subaru ECUs out of a 2007 Subaru Legacy. And the reason I chose to do this is not like we haven't done quite a few cloning videos in the past. But the reason I wanted to do this video, there's two reasons. One, the EPROM in these ECUs is a 93C86, and I'll try to get a good close-up so you can see it. And there have been other videos on YouTube where people are trying to do the 93C86 in circuit, and they are not successful. Matter of fact, they won't even try in some cases. They've had such poor results of trying to attach to and read these in circuit. So I thought, one, I would show you that it's, with the right tool, it's certainly possible. And the second thing that I wanted to show you, and the reason I chose to do this presentation, is that I wanted to show you the VIN. And the reason that I wanted to show you the VIN is the VIN in these modules is stored in a way when you first look at it, it looks like it's there's a problem with the way the characters are arranged. And I want to show you that, and then I want to show you a feature of our tool which lets you correct that, at least in terms of if you want to do an edit. For a clone, it doesn't matter because you're just going to be transferring the data from one module to another. But if you were to VIN edit, or if you were to edit the VIN, then it would matter that you did it correctly. And if the VIN character arrangement is not something that you would expect to see, then it would be easier for you if you could arrange it into the normal 17 character sequence. So I'll show you how to do that as well. So let me get these out of their enclosures and we will get started. Okay, I haven't actually taken, I don't think I've done a video recently where I've taken them out. So I'm going to do this. This one is the original here, and this one is the one we're going to clone it into here. So basically, there's just a plastic retainer that covers the connector, and it's got two clips on each side. I've already got this one off. So I'll show you. We'll just take that off, and then it just slides out just like that. And as I said, this is the clone, and so that I don't get confused, I wrote clone on it. And I'll put it aside because we're going to read the original one first, and then we're going to transfer the data. So let's undo the original one here and take it out. And on this guy, I wrote orig, so I would know that that's the original one. So I'll put its enclosure aside. Okay, now the thing that I wanted to show you is I always try to give you a little additional knowledge when I do these videos, so you maybe have a bit more of an understanding of what goes on in a module. I may do just a tour video at some point in the future. So one of the things that occasionally comes up when a customer contacts us or someone that's interested in our products contacts us is they say, how do I get a module repaired, or how can I fix this module myself? And the answer is probably not. Okay, and the reason that you probably can't fix it yourself is that it's extremely difficult to identify which component has actually failed, unless you have extensive knowledge as an electronic technician and you have a schematic diagram for the particular module with which you're working. Repair of that module is going to be extremely difficult. So it's simpler just to get a salvage module and move the data to it. But while we're here with this module, I will show you a couple of things just to point them out to you. Let me zoom in, and so we get a little bit better close-up of the components. Okay, I've zoomed in here. Let me grab my pointer pencil so I can point to some things on this this module that you may find of interest. If you don't, you can just fast forward past this part of the video. But a couple of things. This giant chip here that I'm pointing to, this is the processor, okay? And this is the component which does the actual management of the engine. They may have other tasks built into this module and that this module is responsible for, but all of these pins, if you look around the periphery of this part, it's got lots and lots and lots and lots of pins, okay? They're all hooked to various components which are either driving things like fuel injectors or air control motors or whatever the engineering community or engineering team decided that this was going to have to control. Logic levels on those pins are going to be doing the switching or reading inputs from the mass airflow sensor or temperature or whatever other sensors are going to be required in order for the program which is running in here, okay, to do its job. All right. And something else that is I'll show you right here. This is the crystal. Okay, this establishes the speed at which this runs. Okay, so there's the program that's in here is running around executing its instructions one instruction at a time as quickly as it possibly can, and it's reading inputs, providing outputs, and all of that. But the speed at which that's happening is established by this component right here. And I found something else interesting. If you look over here, there's another crystal. Okay, this crystal apparently is attached to this component. So this is another processor of some type, and I don't know what that does. It does some, in order for it to, this is also something that's executing a program, but I don't know what it's executing. I kind of can guess at what some of the other things are, like these components look like they're drivers of some type, as are, this is a transistor over here, something big it's controlling. Here's another one. These silver can components are capacitors, and if you look down around, sprinkled around the processor in this area are resistors and little capacitors. So all of these components work together in order to establish the function that this module does. And it isn't uncommon with the complexity of vehicles today to find, you're going to have a minimum of one processor running its program, but sometimes you'll find two or three, depending upon, the more functions they can put on a module, the less it costs them to fabricate that assembly. So if they can squeeze, another processor doing something else, even though it might not be related to engine management, they might put it on here. Okay, but it's also not something that you're going to be able to identify if there's a failure. Let's say one of these transistors fails, without knowing which one, or having a schematic which is going to provide guidance for you. You're not going to know. And then all of these things feed to the connector where the wires, the plug attaches with the wires that go physically out to the different sensors and other things that are either going to be sensed or activated. Okay, so anyway, I just provide this information. For me, I always wanted to know how things worked. And unfortunately today, it's almost impossible unless you've got, the supporting documentation, meaning schematic diagrams and some way to, if you're going to try and fix something like this, beware of companies that say, well, yeah, we reconditioned it. Really? What did you do? Okay, when you reconditioned it, what did you do? A lot of times they'll recondition it simply by cleaning the dirt off the outside of the enclosure. Because basically, if it was functioning properly before the collision that rendered the vehicle, unusable, then it probably is good. Aside from the fact that it's programmed to the vehicle, which is now no longer functional, and that's why you can't just take a module out of a salvage vehicle and place it into another vehicle, because the programmed data, not the program in here, okay, but the vehicle-specific data, the VIN, if it's got an immobilizer, you're going to have key information, and anything else that would be specific to the car, that's also going to be here. But usually it's something like the VIN, which is going to prevent that module from being accepted by other modules in a different vehicle, because it doesn't have the same VIN as the other module. So anyway, we're going to address that in a minute when I do the clone. So let's find the EEPROM on this module. And if EEPROMs are typically, they're an 8-pin component. They are one of 3 families. If you look at our tool or other manufacturers' tools, you'll see that there are 3 families. There's the 93 family, the 2595 family, and then the 24 family. So your EEPROM is going to be hopefully numbered in a way that you can determine that. Not always, but we provide a document with our kits that give you guidance when it comes to how to locate and identify those parts. So the other thing I want to point out is that 8-pin parts are the 8-pin package. It's just the data carrier for a little piece of silicon, meaning that just because it's an 8-pin package doesn't mean it's an EEPROM. It means it's a component of some type, but you can have, for example, if you a lot of 8-pin parts, you'll see a number with 2903, 2904. Those are analog amplifiers. Okay, meaning you might want to take the signal coming from an oxygen sensor and make it bigger. So the analog to digital converter on the processor, silicon or separate, depending upon how it was designed, is going to be able to see the value of oxygen content in the exhaust. Okay, but the signal from the sensor might be little and tiny, and you need to make it bigger. So they would use an amplifier in order to do that. So if you see a 2903 or 2904, that's what those are, and they are not EEPROMs. They are amplifiers. So just because it's an 8-pin package does not mean it's an EEPROM. Okay, well, there are some 8-pin parts here. There's one here. There's one here. I don't see any others. Anyway, I've already looked at this. I'm going to tell you that the EEPROM is not on this side of the assembly. And when you are looking for the EEPROM on your assembly, look on the other side, okay? Because there are other 8-pin parts on this side of the assembly, okay? We've got one here, and we've got one here, and we've got one here. And let's see, we've got one here, all right? So we need to identify which one of these is the actual EEPROM, which holds the vehicle-specific data. And the way that you do that, gosh, I wish there was a website somewhere where you could just key in your module with which you're working, and it would pop up and say the EEPROM in this module is this one, and here's where it is. But there's not, at least not one of which I'm aware. So you're going to have to do it the old-fashioned way, and that is you're going to have to look at it. Okay, meaning you're going to have to get, at least for me, as I have aged, my eyesight has not improved. So I use a set of magnifiers in order to determine which part is the EEPROM. And I'll just show you something else while I'm doing this. There is a product called a conformal coating removal pen. And I'll just slide over here and get it so you can see it. Okay, we don't sell this, but you can get it on Amazon, and I think other distributors sell it. It's made by a company called Tech Spray. The part number is 2510-N. I think I showed this in another video, which we did. But anyway, this is a handy way to, because these modules are going to have what's called conformal coating on them. And the reason they spray conformal coating on the modules is because the module will be exposed to a humid environment. And in a humid environment, if it doesn't have some kind of protective coating on it, you're going to get possible corrosion of the solder, the underlying components. You just never know. I believe we did a video where I actually showed a couple of two modules. One which it didn't get wet, but it wasn't really, didn't have much conformal coating on it, and you could see where it was getting starting to corrode. Anyway, this is it's like a magic marker, and what you do is it's got the tip here is nylon, and it's like a nylon bristle, and when you push down on the top on the pin on top of your component, some of the internal fluid will pass through the nylon bristle and get on the top of the component. Then you can rub it, and basically it removes the conformal coating, which then allows you to see the number that's printed underneath. Be careful. This will not take the ink off. At least I've never seen it take the ink off. Or the number, or the printed number on the EPROM or any other component. So you can just go along and scrub these things until you figure out which one is the EPROM, and then once you do that, then you know which part to select. Okay, and it doesn't hurt the component at all to do that. This is very, it will attack plastic. So you want to be sure and not get any of its removal fluid on anything plastic. So we have a scar on our grid here caused by a leak from the conformal coating removal pin. But anyway, this is something that we use, something that we recommend, not something that we sell, but you can get it, and it's a very, very nice addition to your arsenal of tools. So I will tell you where the EEPROM is on this assembly, since I've already located it previously. You never do a video until you have figured out stuff beforehand, okay? And this EEPROM is right here, all right? It's right here in the corner. It's a 93C86. So what I'm going to do is I'm going to zoom in as best as I can so you can see the part number. So give me a minute and I will do that. Okay, I got a light shining on the EEPROM so you can see the part number. That's what the big blue thing is at the bottom of the screen there. You can see it says 93C86. Not going to hold it there long because my hand is going to slip. But that's the part number. I just wanted you to be able to see it so you know what you're looking for. And this is why when you're doing this kind of work, when you're doing EEPROM work, a magnifier and a good light source will be your friend. Okay, so that is that. That's how I'm identifying the part number. And this is a part with a dot where pin 1 is. And let me take the light away because that's not going to be helpful. But if you, I'll point out with the pencil here. I think. Okay, it's the upper left-hand corner of this part. I got this assembly sitting on a box. That's how I got it up close to the camera. There's a dimple right here, and they also, on the silk screen, you see they put this little triangle? That's how they indicate pin 1. Okay? So this is pin 1, and 1, 2, 3, 4, and then 5, 6, 7, 8, where pin 8 is across from pin 1. All right, so that is our EEPROM, to which we are going to attach, and we are going to perform our clone. All right, so let me move it back down so it's not sitting on this unstable box, and we will carry on from there. Okay, in order to do this clone, I put the piece of white foam under this assembly so that it's basically level. Before I proceed, I'm going to show you. Here's the programmer. I'm going to use the AccuTouch probe here. I'm not going to use the clip. Here's the AccuTouch probe. The programmer has been described in many of our other videos, so I'm not going to spend time showing that. AccuTouch probe here with the 8 4-point crown pins, spring-loaded pins, which we'll just push over the top of the part. And this is the plug. All of our connection options, probes, clips, whatever you happen to purchase, or what comes with our kits. They'll have a black plug, and this one is on the 93XX because that is the family of EEPROM with which we are working. So that's the programmer. I'm not going to show you any more than that. There are plenty of other videos which show that. So I'm just going to put that up for now. And then, let's see. I think my work area here is a bit crowded because of other stuff sitting here. But let me show you how this works. Put this over the top of the part, like so. You've seen it. If you watch our other videos, you see it. You've seen this work. And then you just push down. Okay, now this has been cleaned with the conformal coating removal pen, so there's no contamination on the the pins of the device. But if there were, the AccuTouch probe does a really good job of penetrating the conformal coating. Okay, so let me switch back over to the. I've already got the software set up. Like I said, I don't want to go through rehashing a whole bunch of things that we've done over and over again in other videos. The computer is already set up with the device selected. And let me go over to that screen. Alright, so we're on the computer screen here. Notice it says 93C86, just quickly to show how I knew where to put the probe and how to set the adapter. When you select the part, it'll automatically come up and show you. If you look down here, it says how to set the programming unit, how to set which adapter you need, how to set up the adapter, and it'll say plug or device position left. Okay, 93XX. We always tell you how to set up the system. As I said, I've covered this before, but just a quick review. So, let me now, as you've seen me do in the past, we're going to go to Command 5, and we're going to be sure that we are attached to the part. So we'll do that. Command 5, there we are in the buffer editor. Alright, I have the AccuTouch probe attached to the part, and we'll go back to the computer screen, and I'm going to press Q for quick view to be sure we are attached. There is the data from the module. Okay. Now we're just going to read it. We're going to read it by pressing Command G, which you have seen me do in the past. Command G is get valid data, so it's going to read the part into the buffer. The buffer is just the area in which we allow you to work with data. And then it's going to read it again. After it reads it the first time, it's going to read it a second time and confirm that what's there, what it read the first time, matches what it reads the second time, and it will leave that data, which is valid, in the buffer. If it's not valid, it will say part and buffer do not match. It means that the data is not good. So we'll press G, and you'll see it read the data, compare the data, and there it is. Okay, so now we have that data in the buffer. And this is what I wanted to show you before I finish the clone. Okay. If you look here, let me get the mouse. Just move over here so you can see it. This has the VIN, and the VIN is stored 4 times. I did another video which showed the VIN being stored 4 times, but this is a big clump of VINs here. I don't know what this information is up here, but the VIN is a 17-character string, which is stored in its hex, okay, meaning that ASCII is a way for human beings for hexadecimal characters to map to human readable characters. Okay, and just quickly, for example, this hexadecimal 53 here maps to this uppercase S here. Okay, and the VIN in this case, this is out of a Subaru. Okay, and the VIN, if you look at the VIN, VINs don't start with the letter S. Okay, the first letter of the VIN indicates the country of manufacture, and since it's Subaru, this appears to be inconsistent in the way that it appears. And let me clear the information display here. Press the space bar. Why? Why does that happen? Okay, well, the reason that it happens is that the big processor, the chip that I showed you before, is a 16-bit processor. Okay, it's going to be, and if it's a 16-bit processor, many times the way that a 16-bit processor will store its data, since a VIN is an individual byte, okay, an individual 8 bits. The characters are individual 8 bits, individually 8 bits, or a byte. But it's 16 bits, so you're going to get 2 bytes or 2 characters of the VIN, which are going to be stored. Well, they can either, depending upon the processor that they picked and the guys that wrote the code, they'll either store them with the first byte in the lowest location in the memory, or the second byte in the lowest location of the memory. Okay? So in this case, what they've decided to do is store the second byte in the lowest location of the memory. Okay? And the first byte is in the second location in memory. Okay? By first location, I mean here at 30. All right? And the second location is here, which would be 31. All right? But the first character in the VIN is a 4, meaning that with 4, that means that this vehicle was manufactured in Canada. And the S means that it's a Subaru. All right? So you're looking at this number going, what? Why is that appear to be all swapped? Why are those bytes swapped? Well, it's because that's how the processor stored them, and it's a 16-bit processor. It doesn't happen all the time. Sometimes you can see the VIN, okay, and it's clear, and they stored it in order, okay. But in this case, that's not the way they did it. All right. So what if you were doing a VIN edit? It would be difficult for you to basically enter the value for this VIN with the characters being swapped. Okay, you'd have to do this one, then this one, then this one, then this one. Okay, and it would be not exactly straightforward to do that. Our software has the capability to allow that to be easily corrected with a command called byte swap. Okay, and I'll just show you that now. To access the byte swap, it's an editor command, and I'll just show you how you would know you have that. Okay, we're going to press the question mark key, which is going to take you to your help screen. And we have B here equals byte word data manipulation, swap bytes, or nibbles, okay, or even or odd. So in order to perform a byte swap, you just press the B command. All right, so I'm going to go back to the screen, and I'm going to press B for byte swap, and then down here you'll see that it says byte word data manipulation B equals swap bytes. Okay, so I'm going to press B again, and you will see that now the VIN looks normal. Okay, 4 made in Canada, S Subaru. I don't know what this 4 means, or the rest of it. If you want to know how VINs are encoded, there are a couple of great videos on YouTube which you can watch. But anyway, let's store this VIN 4 times. Here's the first one, and it ends right here, and then they've got a byte of zeros right here, which don't map to any printable human character. So we show it as a period or a dot. And the VIN is here again. Okay? And it goes over here, 70 more characters and another 0, which separates this VIN. It's the second VIN from the third VIN, which is here. So they store the VIN here 3 times. Now, if you wanted to edit the VIN, I'm not going to edit this VIN because we're just doing a clone. Okay? You would use the modify command. You would press M for modify, and this we would start with this VIN on line 30. And press enter, and you would then go through, and the way that our software works, you just type the VIN that you would want to enter and move it across, and they would change as you did that. And that's how easy it would be to change the VIN, because now what you see is the correct order of the VIN. So it would be a lot simpler to do that than to figure out, you know, which byte to change in order to get it to work. Anyway, I wanted to show you that. Now, after you do the byte swap, don't forget, and if you're doing a VIN edit, don't forget to swap it back, otherwise it's not going to be correct when it's stored in the EEPROM of the module. Okay, so that is what I wanted to show you about 16-bit processors and how data is stored. I'm going to use the B command again, and I'm going to say swap those bytes back, and now it's back in the format that the module expects it to see. Okay, so in order to complete this clone, all we got to do is program this data from the old ECU, the original ECU, into the salvage unit. So let me get the salvage unit. I'm not going to belabor the presentation with me taking it out of the box and everything. I'll just get it set up, and then we will perform the clone. Alright, I've got the AccuTouch probe in place over the top of the 93C86. I'm going to do a quick view so you can see. Let's get back to the computer screen. Quick view, you can see that the data is different. If you watch the VIN numbers, you can see that the original one is a last 2 digits are 5116, and in the salvage module it is 4216. Okay, so this is the original one, this is the salvage module. Alright, so all we have to do is program the original into the salvage unit, and we do that with command 2, which you have seen on other videos. So we're going to press 2, which is program device from buffer start, address 0. When we want to do that, yes, programming device. We program it, then we make sure it's right, verifying after programming. We are done. Okay, so this module is now cloned. You notice I didn't have to save the data. Okay, I just read it and changed the module, and we programmed it, and we're finished. No, nothing else. So I just will put these back in their enclosures, and when they are arrive back at the vehicle, all they got to do is install it in the car, and it should start up, and the problem that is existing should be gone as long as the salvage module was electronically sound, and the problem was indeed the salvage module or the original module. Okay, if you clone a module and the problem with which you're trying to solve remains, well, then it wasn't the module. So that pretty much wraps up this video. We appreciate the time that you invested watching it. We would, as I've said in the past, Andromeda Research, we are not a big business, but we are in the United States. And if you would like to converse with us about our products, or you have any questions about anything, you may call us. The information is available on our website. And once again, we certainly appreciate the fact that you've invested some time. And if you would choose to purchase our products, we would certainly appreciate that as well. So once again, thank you for watching, and the information, as I said, is available on our website, which is arlabs.com.